Hello, this is Mr. Collier, and today we're going to be factoring quadratics that are a difference of squares. Okay, so there's a difference of squares pattern that develops if you have a number or a value a plus a value b multiplied by the same values with both a subtraction sign in between. Then you'll get just a squared minus b squared. So what that means is if you got something like x minus 3 times x plus 3, then when you multiply, well, let's see what happens. You're going to get x squared, and then x squared plus 3x minus 3x minus 9. So you see the positive 3x and the negative 3x in the middle will cancel, and you get x squared minus 9, which is exactly equal to x squared minus 3 squared. Okay, so this happens with any two binomials like this. Also, if you have an expression like a squared minus b squared, for example, this expression, x squared minus 36, then you can work backwards and find out what two factors multiply to give you this. Okay, so if we go from this to this, that's expanding. And if we're going backwards, that's factoring. Okay, so if we want to look at this pattern and help us factor this, we can see that this is a squared, then these numbers here are going to be a and a. So basically you take the square root. Square root of x squared is x. So you're going to have x here. You're going to have a plus and a minus. And you have b squared here, which is 36. So you're going to have b and b over here. So it's basically going to be 6 and 6. And we can multiply this out, and we will get the same thing here, the same expression, x squared minus 36, just like we did over here. So we're going to use this pattern to do some factoring now. So we look at the first expression. We got x squared minus 49. First of all, check to see if it is a difference of squares. It is a difference because we have a subtraction, and x squared is a square number, and 49 is a square number, so we can factor it using the difference of squares method. We're going to factor to x minus 7 times x plus 7. Okay, and we can check that by multiplying x minus 7 times x plus 7. You get x squared plus 7x minus 7x minus 49, and then the 7x and the negative 7x in the middle will cancel, and this will always be the case. So it is true. Okay, so in the next example, we've got x squared minus 81. Okay, the square root of 81 is 9, so it's going to factor to x minus 9 times x plus 9. In the next one, this is also a difference of squares. Okay, because this is a square number. 25 is 5 squared. Y squared is y squared, of course. So it's going to factor to 5 minus y times 5 plus y. Okay, in the next couple of examples, it's the same deal. We've got difference of squares. Okay, so 16x squared, well, that's just 4x squared. You get the square root of 16x squared, you get 4x. And the square root of 100 is 10. So it's going to be 4x minus 10 times 4x plus 10. In the next example, we can, both of these are square numbers because you can get the square root of both of them. And it's a difference, so it's a difference of squares. Square root of x squared is x. Square root of 4y squared is 2y. So it's going to be x minus 2y times x plus 2y. And then the last example here is again a difference of squares. We get the square root of a squared, we get a. And we get the square root of b squared c squared is just bc. and that's going to be a minus bc here. Okay, a few more examples. Now, here in this example, we don't have a square number here. 50 is not a square number. But what we do have is a greatest common factor between 2 and 50, which is 2. So we can factor out the GCF first, and that's going to be 2 times x squared minus 25. And now we have a difference of squares inside the brackets. We can get the square root of x squared, we can get the square root of 25. So we can factor that using the difference of squares method. So that's going to become x minus 5 times x plus 5. Now the next example, this is a square number, but the problem is we don't have a difference of squares. We have a sum of squares. Okay, so this is easily fixed. One way we can do it is factor out a -1. Another way is we can simply rewrite it as 64 minus x squared. Okay, so now we have a difference of squares. And that's going to factor to the square root of 64 is 8. So you're going to have 8 minus x times 8 plus x. And in the final example, one thing that we can do here is we can factor the GCF. We don't have a numerical GCF, but we have x squared and x to the power of 4. So the GCF is x squared, the lowest power of x. So we can factor out x squared, and we're left with 81 minus x squared once we factor out that x squared. Okay, so we're not done yet. We can also factor this expression in the brackets because it's a difference of squares again. So we have x squared, and root 81 is 9, so that's going to be 9 minus x times 9 plus x, and that is our fully factorized form of the expression.